Hi, Assalamualaikum. My name is Nur Haliza binti Muhammad Azami. My metric number is 54891, okay? Okay, for the introduction, financial theory is our chapter which is a fairly brief introduction to some of the basic financial problems such as the basic theory of interest rates. Time and uncertainty are the main themes of finance. Time is important because of under normal economic conditions, $1 is worth more than $1 tomorrow. Even if we do not consider inflation, it is reasonable to expect that if we have $1 now and do not need it for immediate consumption, we could go to a bank, deposit our dollar, and then recover a larger sum later. If we get 1 plus R dollars after 1 year, we say that R is the annual interest rate. We might see it the other way around. If we borrow $1 now, we will have to give back some more in the future. Indeed, one function of financial markets is simply to shift consumption over time by borrowing or lending money. If we invest money over a relatively short period of time, we could assume that we know that the interest rate that we apply for that period. This may not be the case for longer periods since interest rates are subject to uncertainty. If the interest rate is reset on a periodic basis under prevailing conditions, the investment is subject to uncertainty, which may be considered a risk of reinvestment. There is a wide range of assets in modern financial markets in which we can invest our money. The main assets we deal with may be classified as bonds, stocks, and derivatives. We will therefore see in this report that these basic problems are strictly linked. We are dealing with simple fixed income instruments, which is bonds in income securities and numerical integration method. In the course of the exhibition, we use short MATLAB snapshots to illustrate the material with examples and make it immediately useful.
Hello and Assalamualaikum. So here I will explain to you about basic pricing of fixed income securities that appear in chapter 2. So here what is the basic pricing of fixed income securities? A fixed income securities is an investment that provides a return in the form of fixed periodic interest and payments and eventual returns of principal at the maturity. And the bonds are the most common type of this fixed income security. Hello and Assalamualaikum. My name is Nur Syabirah binti Harisi. So here I'm going to present to you about example of basic pricing fixed income of securities. As you can see here for the example 1, I had solved this problem by using the MATLAB and I had run the coding, and we can see that we have 7.2% decrease the value of the bond. So here we note that this loss occur only if you have to sell the bond before the maturity. And now what if I change the maturity from the 8 years to 18 years? So I tried run the coding again, and we see that the loss now is much larger, almost 60%. So here we can conclude that the longer the maturity, the more sensitive yet change the bond price is. Apart from that, the coupon rates also play some role too. So here I compare the two bonds with coupon rates of 5% and 7% respectively. So as we can see here, we see that the lower coupon rate will implies a larger sensitivity. So in the conclusion, in the example above, we have just captured this complex change in one measure, and it's depending on the maturity and the coupon rate, we have seen that the bond may be more or less sensitive to a change.
Hi, Assalamualaikum and a very good day to everyone. My name is Shahida binti Shahrudin. My matrix number is S55276, and here I am going to present to you about Monte Carlo integration. Okay, what is Monte Carlo integration? Monte Carlo integration is actually a technique using random numbers, or we can say numerical integration. It is a Monte Carlo method that computes integral numerically. Monte Carlo randomly selects point at which the integral is evaluated. This method is especially useful for higher dimensional integral. I've made an example to give a better understanding about Monte Carlo integration. Consider the trivial case, which is the value is approximately equals to 1.7183. In MATLAB, a call like ran bracket m, n yields a m times n matrix of a uniform random numbers, which parameters m and n have nothing to do with the distribution at all. As you can see in the coding, we randomly change and replace the parameters with any uniform random numbers, and I choose 10 and 1 million. Based on the result, as you can see, as n gets bigger, the error is reduced and the value gets closer to the exact value, which is 1.7183. So, the method is more accurate as n gets bigger. So, for the conclusion, we see that the estimate is not quite reliable when m equals to 10, whereas the variance of the estimator is much lower when m equals to 1 million. The result gets closer to the correct number. To conclude, we do not know the exact result in practice, so we should improve on how to qualify the reliability of the estimate.
My name is Susanna binti Syari and I will present Introduction. This study is about a real application of Monte Carlo simulations in finance that related to numerical method. Monte Carlo simulation means a statistical method that applied in financial modeling. Monte Carlo method use numerical method solutions to avoid the need of spacious algebraic computations and approximations. Problem statement. Monte Carlo method has attracted the attention of many researchers and practitioners because it is of implementation and stability to model disturbances for complex problems. There are two steps of Monte Carlo methods. First, simulate the random quantity of interest, and second, estimate the expected value via sample average of simulated variates. Monte Carlo simulation often shows slower convergence rate than traditional numerical methods. The question is how to reduce variance and accelerate the calculation of Monte Carlo's estimate of the Laplace and transformation of the exponential Brownian functionality.
Hello everyone, my name is Shafika binti Zulkifli and my metric number is S54981, and here I want to present about problem solving in Monte Carlo simulation. For example, you can consider the problem of estimating EP in bracket F. Important sampling change both the probability P and the random variable F to reduce the variance. If Q is a probability measure equivalent to P, then you can see the formula. Glasman at 1999 considered the asymptotic approximation of the second moment and minimized the approximation over set of probabilities equivalent to original one in a finite dimensional setting. The solution for the calculus of variation problem gives us an asymptotically optimal importance sampling measure for Monte Carlo simulation for the Laplace transform of exponential Brownian function. So, for the conclusion of this Monte Carlo simulation, we have studied now to reduce and accelerate the calculation of Monte Carlo simulation, estimate of the Laplace transform of the Brownian functionality by using popular methods for variance reduction. Thank you.